So today we're talking about functions. This is kind of more vocabulary more than anything else, but it's important to understand what we're talking about. A relation pairs any inputs with any outputs. When a relation is given as ordered pairs, the x coordinates are called inputs. The y coordinates are called outputs. Okay? A relation that pairs every input with, and key phrase here, exactly one output is called a function. So anything that pairs inputs with outputs is a relation. Some of the relations are also functions if every input only has one output. So we'll talk about some of the differences as we go. So determine whether this relation is a function. So again, these are all definitely relations because I see x and y's and all these are ordered pairs. So these are all relations for sure. The question is, are they a function? So what I want to look for are, we're going to look for x coordinates that have a different y output on one of the other points within the set. So, for example, -2 goes in and 2 comes out. So a new input, -1, goes in and 2 comes out. That's okay, because -1 and -2 can also have a 2 output. Just like 0 goes in and comes out as a 2. That's okay also. Then 1 goes in, comes out as a 0, 2 goes in, comes out as a 0. So this first one is a function. So I'm going to write yes. And the reason is each input has one output. So it's okay that different inputs share a common output. They just can't have one input with different outputs. So let's look at the next one. So looking at this set, 4 goes in, comes out as a 0. 8 goes in, comes out as a 7. 6 goes in and comes out as a 4. 4 goes in and comes out as a 3, and 5 goes in and comes out as a 2. Well, here we have the problem. So the problem with this one is, this is still a relation, because these are all inputs. But here, we have 4 going in and becoming a 0, and also 4 going in and becoming a 3. So when this happens, it's still a relation, but we can't call it a function, because 4 can't have 2 outputs. So again, it's not that we can't continue with the problem. It's not that we can't graph this. It's not that we can't do other things. We just simply can't call it a function. So then we will see these as tables also. So it's no different. We just don't see them in ordered pairs. But in table form, the x's are up top, the y's are at the bottom. And looking at these, all of these, -2 can go and come out as a 3, -1 comes out as a 4, -0 is a 5, 0 is a 6. So right away, without even finishing the rest of this, we can see right here is our problem. So this is a no. 0 has 2 outputs. Okay? And then the next one. So this is called a mapping diagram. You may or may not have ever seen these before. We talk about these in Math 8. I'm not sure if you saw them in grade 7 or not. But basically, it's the same thing. What it's trying to do is organize another way of showing our ordered pairs. So basically what you're doing is your inputs, or your x's, are over here, and the arrow leads to the output that it belongs to. So for example, if I wrote the ordered pair, this would be -1, 4. This would be 3, 15, and this would be 11, 15. So the question is this a function? So sometimes we will say no because of this thing right here. But remember, it's okay that 3 is 15 and also 11 is 15. So this would still be fine. We can say that this is a function. So we're going to say yes, all inputs one output. So then we see this thing called the vertical line test. So basically, when we look at any graphs, so far we've looked at some ordered pairs, we've looked at some table, we looked at the mapping diagram. Now we see a graph. So in the graph, what you want to look at is, we have this thing called the vertical line test. So we all know that a vertical line goes straight up and down. So that's what this dotted line thing is. So basically, if I have a graph, I can just start putting a vertical line through all of my points as I come across the graph to see if every input has exactly one output. So remember, my inputs are the x values. So if I was to set up a vertical line and just bring it across the graph, my vertical lines should only hit one point at any x as I go across, because remember, the outputs are the y's. That would keep it a function. And then comparing it to this graph, if I was to put a vertical line anywhere on this graph, I'm going to hit multiple points. So the one that they give for an example, it has this output, but also this output. So it each has two outputs. Okay? So if it doesn't hit more than one, you would say it passes the vertical line test, so it's a function. If it hits more than 1 point on the y's, then it would not be a function. So let's use the vertical line test for these here. So looking at these, do we think that this is passing the vertical line test? So the first one, hopefully we can see pretty quickly that at x equals 2, if I was to do my vertical line, aren't I hitting 2 points? Also, when x's are 5, same thing happens. So is this a function? No. 2 and 5 have 2 outputs. Okay? Again, it's still a relation. It's still a graph. I can still make the graph. I can still use the graph. It's not that I can't do anything. I just can't call it a function. On the next one, if I was to place any vertical line across this as I go horizontally all the way through, I am only going to hit 1 point above every x value. So we would say, yes, all inputs have one output. So it can be called a relation, but also a function. So then we have these next two words, or vocabulary again, kind of talking about the same things. We have the old function machine where you kind of have the input of a -2 going into the function. You can see the y equals 3x, which would mean plug in the x as the -2, and it spits out the -6 as the output. So the other terms that sometimes you are going to be referring to these are, this is called the domain. The domain is all of the possible input values, and the output values are called the range. Okay, so it's vocabulary we want to be ready to use when we have questions about domains and range. So on the next one, find the range and the domain of the function represented below. So basically what you're going to do is we're just going to look at, I'm going to abbreviate domain as the D, all of the x values of the points you see. So for example, this first point right here is at -3, -2. This point is at -1, 0. Then this point is at 1, 2. And this point is at 3, 4. So the domain of this graph are all of the x values. So we use this little set bracket. It's kind of like a parentheses. It's kind of been squished in a little bit. So this would be a set bracket. I'm going to list all of the domain values in numerical order. So if they weren't in order, I'd want to make sure that they were in order. And then I just close it when I'm done. Then I would move on to the range. The range is the set of all of the y values. So negative 2, I have a 0, I have a 2, and I have a 4. On to the next one. So here you can see we can't write all of the points. We're going to use our inequalities for this one. So on this one, if I do my domain, this is going to be the x values. So remember, my x values, or the domain, go this way, right? So all of my x values are going to be between greater than or equal to negative 2 and less than or equal to 3. It's covering every single x value from the negative 2 all the way across to the 3. Now my y values, or my range, if I go to this, now my y's are focusing here. So I have y's at this value down here, negative 1, all the way up to and including the positive 2. So when I write this one, I write y, because now it's the y values, greater than or equal to negative 1, less than or equal to positive 2. So when you have that continuous line, you need those inequalities to cover the x's and the y's, or the set brackets when you have just individual ones. Then we have two more vocabulary words to talk about. We have the variable that represents the input values, which are my x values, which are also the domain. They are the independent variable. So x, or inputs, think in is independent, because they are very independent. They can be any value in the domain. The y values, or the outputs, so the y's are the outputs, these are called the dependents. Basically because they depend on what the x's were. The x goes in, so it can be anything. Run it through the equation, and the y comes out based on what went in. So the y values are our dependents. The independents are the inputs. Those are the x values. So again, we start seeing equations. If I see this equation as my example, this is the dependent. This one over here is the independent. So it's the one that kind of gets stuff done to it, and then that comes out based on what went in. So then let's look at the last couple of examples here. So here we have the function y equals negative 3x plus 12 that represents the amount of y juice remaining after you take x gulps. Identify the independent and the dependent variables. So independent would be my x values. The dependent are my y values. Now in this case, because we're talking about a word problem, we need to say, well, what are those things in this one? So the independent, I'm just going to abbreviate it this way, is the number of gulps that you're going to take. The dependent is going to be the amount of juice left. Which makes sense. You don't know how much juice is left until you determine how many gulps you're going to take. So we're going to be talking about what these equations are telling us. It's going to tell us a couple of things here, which we'll talk more and more about as we go through the year. But this equation, if I was to start this way at the beginning, I could tell you the amount of fluid ounces in the juice to begin with, which is this number right here, the 12, because I haven't taken any gulps yet. So if I was to plug in my no gulps, or 0, it would tell me that I'm starting with 12 ounces. This negative 3 here tells me how much each gulp is of the fluid that I'm taking. Basically, each gulp in this situation is 3 ounces. That's how much I'm drinking for each of my gulps. So the domain is 0, 1, 2, 3, and 4. What is the range? So you can do this in a couple of ways. Let's just do this real quickly as a table. So remember, if you are doing a table, the x and the y tables, basically the way a table works, the domain are the x values, so I'm just going to even plug those in because we know what those are going to be. And if you remember back from making tables, what you're going to do is take your equation and plug in the x and solve for the y. So I'm just going to do a couple of them to see that you can see how they work. So y equals -3 times 0 for the first one plus 12. So I'm going to plug it in. That's going to tell me that when y is 0, -3 times 0 is 0, plus 12 means 12 comes out. When 1 goes in, I now change that x to a 1. I get -3 plus 12 means when 1 gulp happens, there's 9 remaining. When I do 2 gulps, I would plug in x as 2, and I would get -6 plus 12, which means 6 comes out. If 3 goes in, -3 times 3 is -9 plus 12 is 3. And if I take 4 gulps, -3 times 4 is -12 plus 12 means 0 is remaining. So that's how you would create the table. Now the question says, what is the range? So remember, the range is simply the y values. So I'm going to write them in numerical order: 0, 3, 6, 9, 12. And that would be the answer to this because it's asking for the range. There it is, and how you get to the work. And that's how it goes for functions. A lot of vocabulary more than anything else, but it's important that we understand this vocabulary. We'll be using it throughout the rest of the year, and we need to understand what we're talking about when we mention inputs, outputs, relations versus functions, domains versus range, and looking at independent and dependent variables. So hopefully this makes sense. If you have any kind of questions, please ask me when I see you in class.